This is Tim Hegarty with the Virtual Training Company C++ Fundamentals. We are going to look at exception handling now. Modular programming has caused error handling to have to be split into two distinct operations. We now have multiple functions and classes and libraries running around out there that are detecting errors, but they don't know what to do about it. They have to give those errors over to some other local code, which our new user is writing, our new developer is writing, so that they can deal with the error and report it or resolve it in some way. So, the reporting of errors has to be taken care of, and the handling of those errors has to be taken care of. Two different sections, reporting and handling. We're going to do that with a new construct called the try, throw, catch. It's really pretty simple once you see an example of it. Try is a statement block. You see the braces there, an open and closed brace, and it will have a bunch of C++ code inside it. That's the code that we're going to try to perform and see if we can do it without having any problems. If we hit a problem someplace inside the try, we will throw an exception, and an exception is just a type. It's a class or an integer or a character or something like that. It's just a type. That is used within the trying code to report that an exception has occurred, and now somebody has to deal with it. The catch statement block is written directly after the try statement block, and the catch block will contain the error handling code that can actually do something about the error. It just depends on what the error is. So let's take a look at a little piece of code that I've put together for us here so that we can prove this out. First, you have to include exception. So that gets your exception handling in place. So we do a pound include exception. I've included IOStream just so we can talk to the outside world, and then we use namespace standard. Now here is a new type. This is a struct called demo error. Doesn't have anything in it, obviously. It's empty, but that does create a new type, and we can pass that thing around. You can do a throw of an int or a character, but that's kind of ambiguous and doesn't really explain anything. Here you can have a lot of different errors, and you can even have information in them so that you can throw information about the error, maybe a file name or an operation you were trying to perform, something like that. It's completely up to you how much information you throw when you do throw it. Now here down inside our program main, we have our try block. This is everything that we're going to try to accomplish and maybe have to throw an error. Right now there's a comment. We'll use that in a minute. Here we set up a long for 100. Here we set a myArray of integer pointers, and we're going to set them equal to a bunch of new integers, a number of them. And in this case right now it'll just be 100. Eventually we'll try to make 1 billion of them, and I guarantee you that won't work. Here we do a bunch of other work, whatever's going on in our try block in our program, and then just for grins we will throw the demo error. So this is how we throw a demo error, which is this thing up here, this structure. So we're going to throw this type, and then here's another line that's after the throw. Well, that's strictly there so that I can show you that we will never get there. When you throw out of a try block, the try block is done. Nothing else is going to get executed within this try block. Now here's our catch blocks. The catch blocks have to be directly after the try block. They have to be the next set of statements after the try block. And we can have a bunch of catches. We can catch all kinds of things coming out of the try block. In our case, we're going to catch our demo error, which is that structure, and we're going to say, I caught the demo error. Obviously, you'd do something important with the error that you caught. Here, I just want to show you we got it. If we don't catch that one, there might be another one we can catch. This is our standard exception reference. So here we're going to catch a standard exception coming from the operating system. In this case, this will catch our memory allocation problem. And there is a method called what, which is a way of finding out what particular standard exception did we hit. So e.what will give us that exception. And here's an everything else. Catch with an ellipsis in it are all the other throws that might come through, and we don't have them specifically noted. Don't have to do that, but it's a good thing to have there so that you can catch other exceptions and maybe do something, maybe recover before bailing out of the program. We'll say something else happened. Down here is the last line of our conventional program. This is the bottom of main down here. So we have our catch, and this is our last line that we're leaving the program. So let's see what's going to happen. We should only get our demo error thrown. So let's run this. And there it goes. I caught the demo error and now leaving the program. He did no other work in that try block after throwing that demo error and catching it. Now let's give him something else to think about. We'll take out our comment here and we'll put it in down there, so that now we're going to ask for way too many integers than we have memory for, and let's see how that works. Standard exception, bad allocation. And again, right after the catch block, we're now leaving the program and press any key to get back here. So that means that we never got to this demo error. As it was trying to allocate too much memory, it failed right here and threw an exception. And since we were in a try block, it understood to start working through the catch blocks, and it found this one. This was the standard exception that was thrown out, and that's what told us our exception. Now that's try, throw, and catch in exception handling. Now imagine in this try block, what if we had made a function call, which called another function, and so on, and we were down deep in the program? Well, stay tuned. We're going to show you how that is handled.